We're going to go through an example of calculating spot rates in this module. This material is covered on page 395 through 399 of the text. In calculating spot rates, we're going to use a method called bootstrapping, and that's going to begin with the calculation of the spot rate for the first time period, and then move our way backwards. We have to begin our spot rate calculation at the first time period because we use information from that calculation in our second calculation, and so on. And again, spot rates, unlike yield to maturities, will not vary across maturities, and that occurs because there's market arbitrage that will cause those spot rates to move to an equilibrium, which should not vary across maturities. I'm going to give an example, a 4-year example. This example has yearly payments, so we're not going to have to worry about semi-annual payments or converting our yield to maturity or spot rates from annual to semi-annual. And we're going to have yield to maturities given to us, and here you see those in the following example. We're going to have years to maturity. We're going to have 4 bonds. The first bond has a year to maturity or a maturity in 1 year. Second one 2 years. Third one 3 years. Fourth one 4 years. All of these bonds have a 5% coupon rate, and you can see the yield to maturities listed there. Our yield to maturity on our 1-year bond is 4%, 4.5% for 2 years, 5 for 3, 5.5 for 4. This is giving us our typical yield to maturity curve that's increasing over time. The next column, or the last column, gives the bond price, and that bond price occurs or causes the discounted cash flows to equal the bond price given the yield to maturity listed in the third column, and you can see the bond prices listed there. One item to note is that our year 3 bond has a $100 bond price. We're assuming here that all of our bonds have a $100 par. The $100 bond price results because our yield to maturity equals our coupon rate for the year 3 bond of 5%. We're going to begin our spot rate calculation in year 1, and in year 1 we're going to begin with our formulas for yield to maturity and our spot rate calculation that you see listed there. We've used these before. These formulas right here are for a bond with 3 payments. Our first bond, or our spot rate, begins with a calculation for our 1-year bond, or our maturity for 1 year. We can simplify those equations to the ones below. P equals C plus M divided by 1 plus the yield maturity, or similarly, P equals C plus M divided by 1 plus spot rate. In both cases, C plus M is going to be equal to 105. Our price we already know, and we show on the other side. If you're looking at these 2 equations, you'll note that the yield to maturity and the spot price, everything else is the same in those equations, and given that, we know that our yield to maturity and spot rate in the first period is going to be equal one another, and our yield to maturity is 4%, so our spot rate is also 4%. Our spot rate for year 2 begins with our spot rate formula for year 2. You see that listed here. We have 1 payment, our coupon payment in year 1, our coupon payment plus our par value back in year 2. We again know everything that in this equation. 100.94 is our bond price. Our coupon payment is 100 times 0.05%, or 100 times 5%, or $5. And that is going to be divided by our spot rate for the first time period, or 4%, plus $105 at the end of the second year, which is our 5-pound coupon payment, plus our par value of $100. You can see that the only unknown in this formula is our spot rate for year 2. If we simplify that, or solve for Z2, we get that Z2 equals 4.5%. So again, what we have here is everything is known from the previous period calculation. We got from there that our spot rate was 4%. We plugged that in for our year 1 4% spot rate. and then we solve for a spot rate of year 2. Our spot rate calculation for year 3 proceeds exactly similarly to our year 2 calculation. Here you see the formula for our spot rate calculation. Again, we know everything in that formula from our previous calculations. Our bond price is $100. We've had that given to us. Our coupon payment in period 1 is $5. We're again going to discount that back by our 4% spot rate for year 1. Our coupon payment in year 2 is $5. Our spot rate that year was 4.5%, so we discount that cash flow back at 4.5%. Our final cash flow is $105 in year 3. We don't know the spot rate for year 3 because that's what we're calculating. If we calculate our spot rate for year 3, we come up with 5%. We then continue on to the spot rate for year 4. Again, here you see the formula giving the spot rate calculation for year 4, just an extension of year 3 calculation for the additional time period, or the 4th year. We again know everything for all of our variables in that equation except for our spot rate for year 4. We've plugged in our $5 coupon payment for year 3, plus we're discounting that back at a 5% rate. We again know the spot rate for year 4. We solve for that and we get 5.56%. Here is a summary of our spot rates along with the other information from this for this problem. We have a 4% spot rate in year 1, which equals the yield to maturity. Our spot rate for year 2 is 4.51%, 5.03 for year 3, and 5.57 for year 4. Again, those differ from the yield to maturity. Again, you can see why from the formula. Spot rates are what one should use in the calculation of cash flows in the future, because conceptually that is what is correct. The yield to maturity can vary across for the same maturity depending on when cash flows occur.